Hello, I'm David Brown from the Solidworks training team. This video presents a project that you can use to hone your Solidworks skills and is easy to make if you have a basic 3D printer. I was working in my shop recently and wanted to listen to some music, so I balanced my cell phone on a block of wood. The sound was okay, but it really lacked in volume and sound quality. Nowadays, people use Bluetooth speakers, but with all the sawdust I create working with wood, I did not want to go that way. And with Bluetooth speakers, I would have to plug it in or consume batteries. My solution requires neither. Besides, why go buy something when I can design and make it myself? The key aspects of this design that I will focus on are design intent, features and multi-body part design, exporting solid bodies, assembly, and 3D printing. Let's get started. I took inspiration for the shape of this design from technology of a bygone era. The body is the main resonating chamber and provides increased bass response, volume, and improves the overall sound quality, which flows nicely out through the speaker openings. I wanted my cell phone to slide easily into the opening and be held securely in place. The face of the amplifier is angled at 70 degrees, and the opening is shallow enough to allow for easy access to all the controls of the music application that I use. The overall dimensions allow for a size that is large enough to produce good sound amplification, yet narrow enough to be able to sit at the back of a counter or desk corner and not take up valuable workspace. The amplifier is designed to be 3D printed. The plates and grills are printed flat, and since the overall length is larger than the capabilities of my 3D printer, the body is divided into two halves. The halves are joined with epoxy adhesive in a lip and groove joint. The face and back plates, with alignment pins and adhesive, provide added strength and stability. This project is perfectly suited for using multi-body design techniques. The result is 6 individual bodies, which can be seen here in the Solid Bodies folder. As you can see in the Feature Manager design tree, I renamed some of the key features such as reference planes for the face and back, speaker and body lofts, and the features that create the lip and groove. I also used folders to organize the features for the face and back plates, as well as the grills. I started by placing a sketch on the top plane with construction lines that I can use to position a reference plane for the amp face at 70 degrees, an inch away from the origin. To create the loft for the right side speaker, I placed a circle in a sketch on the right plane and another one in the newly created amp face plane. I then mirrored the resulting body using the right plane to create the left side speaker. I started with this rather than the body first because it was the main design feature I was concerned about from an aesthetic point of view. I tweaked the size and position of the circles until I had a shape that I was happy with. Before creating the body, I inserted a reference plane that was parallel to the front plane and set back 3.5 inches. This will allow me to control both the front and back independently in case I needed to make adjustments to achieve a desired final shape. I then placed sketches on these planes using the slot command to create the necessary geometry, which makes for a nice lofted body, which is then merged with the lofted body that defines the speakers. I added a fillet on the front and back edge of the main body to my liking. The exact size for this is irrelevant, for it is an expression of artistic creativity or aesthetics. Next was to create the cut for the cell phone to rest in. I made the cut so that it would fit my personal cell phone with its case. Of course, this would need to be modified to fit any particular cell phone case combination. At the bottom of the cut, I added a small boss, just high enough to hold the cell phone in place and yet not block the controls of the music app that I use. Next, I added a small fillet where the speakers meet the body. This completes the shape of the amplifier and is now ready to hollow it out using the shell command, which I define by removing the front faces of each speaker and a thickness of 0.2 inches. After the shelling, I need a cut in the bottom of the space the cell phone slides in. This is centered and just wide enough for the openings at the bottom of my cell phone. This projects the audio down into the chamber of the amplifier and holds up the cell phone at the same time. I finish up the design with some decorative fillets, full round fillets on each speaker opening, and a couple around the opening for the cell phone. At this point in the process, the design is too large for my 3D printer. Since it is symmetrical about the origin, I can use the right plane to divide the amplifier into two parts using the split command. I'll now hover my mouse over the right part and press the Tab key on my keyboard to hide the body. The next features I need to create are the lip and groove that will be used to align and fasten the two halves together. I chose to accomplish this by creating a boss on the left side for the lip. It is half the thickness of the shell wall. Notice the height of the boss is 0.110, and I have added 3 degrees of draft. This is then followed by a corresponding cut on the right side. Notice the depth of the cut is slightly larger than that of the lip. This creates a condition where I can place the epoxy adhesive on the bottom face of the groove, and it has room to squeeze up the side of the lip but not ooze out onto the surface. An alternative to this is to use the automated lip groove command in Solidworks. For my situation, it was much easier and I had better control over the results using a simple boss and cut. Using the automated lip groove command did not give me the exact results I needed at the joint. Now that the main body is complete, I need to design the face and back plates. I used folders to group the features of each of these. Let's take a look at my approach to designing the faceplate. I used surfacing tools to create the faceplate. I selected these two faces and used surface offset with a value of 0, which creates a copy of the surfaces in place. I used surface knit to knit the two surfaces into a single surface, then used thicken to create a body that is 0.1 inches thick, or half the shell thickness. I then added a cut to accommodate the faceplate in the two bodies of the amplifier. On the back side of the faceplate, I used a boss feature to add alignment pins with a small degree of draft. Then holes in each body half that corresponds to the pins. I repeated this same process for the back plate. To create the grills, I placed a sketch on the amp face reference plane and using convert entities of the speaker circle, made a cut to create a small ledge for the grills to rest on for both sides. I then used that ledge face to place a sketch to drive a boss extrude for the grill body on the right side. This was extruded just a little smaller than the depth of the cut to provide a slight setback, again for aesthetics. Unchecking Merge Results ensures I create a separate body. On the back side of the grill body, I created two small alignment pins with a corresponding cut in the amp body. To create the holes in the grill, I used a fill pattern. I needed a sketch on the front face with a circle and a line. The circle provides the boundary for the fill pattern, and the line provides the direction. The rest of the parameters I filled in as shown. Cut through the grill body only. Lastly, I used the right plane to mirror the grill body to the other side and added a cut for the alignment pins. Once the design is completed, I need to export the bodies as individual part files and save those as STL files to send to my 3D printer slicer software. To accomplish this, I expand the Solid Bodies folder, right-click a body, and select Insert into New Part from the context menu. Click the Save button, give the file a name, and save it to the hard drive. When the file is open, I will click Save As, choose STL from the Type drop-down, and click Save. The grills, face, and back plates are printed flat with the pins facing up. Each body is printed standing up. The height was just under the limits of my 3D printer. I used organic supports which have minimal contact with the parts, making cleanup very easy. Typically, I would create an assembly file in Solidworks to evaluate my design for form, fit, and function. However, I used multi-body part design techniques, and this has no moving parts and is simply glued together as is. So I already know the parts will fit together just fine. In order to create the renderings and animations used in this video, I did put the parts together in an assembly file. Once the parts are printed on the 3D printer, and any cleanup has been done, the parts are ready to be assembled. I have tried a variety of adhesives in my projects, and my favorite is a 2-part epoxy. It is easy to use and hardens like concrete, forming a permanent bond. I always advise test fitting the parts prior to applying the adhesive. For this project, I placed a small bead on the bottom face of the groove side of the amp body. I want to make sure that no adhesive squeezed through to be visible at the seam on the outside. I don't wait for the glue to dry. While holding the two halves together, I put adhesive on the back side, around and between the alignment holes, then repeat on the front side. The plates hold it all together while the adhesive cures. For the grills, I put a small dab at the alignment pin holes, and the grills snapped right in place. This was a great design project using multi-body part techniques. It also utilized some more advanced SOLIDWORKS tools like lofts, using reference planes, surfacing tools, and the split command. We also talked about fastening techniques using alignment pin and holes, joining with lip and groove, and using adhesives. I hope you found this video inspiring and you were able to take away some ideas you can incorporate into your own designs. Thank you for watching this video. Stay tuned to this channel for upcoming projects in the Useful SOLIDWORKS Design Projects You Can Make playlist, and if you found this content helpful, visit the site below to access more content for designing with SOLIDWORKS.